Hi guys! How y'all doing? Guess where I am? Well, clearly my classroom, but I'm at parent-teacher conferences. Although somebody's sitting outside. I don't think I have somebody till 5. Hold that thought. It probably looks really weird for people walking by who see me talking to my computer. Anyways, so 2.2, properties of quadratics in standard form. We're going to talk a little bit about vertex form as well, but you know, that's cool. Okay, so define, identify properties of quadratic functions is going to be our SWOBAT number 1. And 2 is identify and use max and mins to solve problems. So, number 1, what is standard formula of a parabola, you ask? Well, if you forgot from the last video, it is a quadratic that is in the form y equals ax squared plus bx plus c, where a, b, and c are all constants. They can be positive or negative, by the way. They're just numbers. Oh yeah, and also a can't be 0, because if a is 0, then you have ax squared plus bx plus c, but a is 0, so that gets rid of that, so you end up with just bx plus c, which is what type of function? A line, not a quadratic. Two different things. So, if a is 0, then it's not a quadratic. Anyways, moving on. Properties of quadratics. Number 1, or parabolas, is the axis of symmetry. Okay, the axis of symmetry. Let's think about this. Symmetry. Remember, parabolas are symmetric. This side is the same as this side. Okay, so the line that cuts it all the way down the middle is the axis of symmetry. That's what it's called. And it always goes through, it has to go through the vertex, right? Whether it's an upside down parabola or a right side up parabola, right? The axis of symmetry cuts through the vertex. So in our parabola right here, the dotted line that you see, that is the axis of symmetry because it's symmetric on either side of the line, right? I could like take this half of the line and flip it over this half and it would be the same. Like this is the line of symmetry of my face because my face is symmetric. Anyways, yeah, axis of symmetry. Okay, so as far as the formula is concerned for the axis of symmetry, since it's always the line that goes through the vertex, is basically whatever the x-coordinate is of the vertex. So in this case, the vertex is positive 1, negative 4. The axis of symmetry goes through the x value of the vertex, which is 1. And so that line, the equation of that line is just that x equals 1, because x equals 1 creates that vertical line, because no matter what y is, x is always 1. If y is 4, x is 1. If y is 5, x is 1. If x is negative 70, if y is negative 70, x is 1. So it creates that line. So that is the equation of the vertex, the line of symmetry. So in this particular case, the axis of symmetry is x equals 1. Next is the vertex, although I've already used the word vertex, so hopefully you figured out what that is. But the vertex is the turning point, where the parabola goes from decreasing to increasing, or the other way, from increasing to decreasing. So in this case, this parabola is going from decreasing to increasing at this point, and that is the point 1, 4, or 1, negative 4, sorry. The y-intercept is where the function intersects the y-axis, and so if you notice, if it intersects the y-axis, x is always going to be 0. So an easy way to find this is to always set x equal to 0 and figure out what y is. That gives you your y-intercept. But in general, it's where it crosses the y-axis. So in this case, the y-intercept is negative 3 right here. And I'm not quite sure why I didn't include it, but the x-intercepts are obviously where it crosses the x-axis. How to find that, we'll talk about later, but basically you set y equal to 0 and then solve for x, but that's a little more complicated. Anyways, all right, so the next pretty important thing, but not necessary, I don't know, I mean it's important, is how to actually get the axis of symmetry and the vertex if the function is in standard form. Okay, it's different based on the form that the quadratic is in, but if you have it in standard form, which is ax squared plus bx plus c, then the vertex is going to be negative b over 2a, and then, so that's the x-coordinate of it. So the vertex is negative b over 2a, and then I would just say this. Basically taking that x-coordinate and plugging it in to x and figuring out what y is for the y-coordinate. Okay. If you are the kind of person who likes to memorize formulas instead, another way to write this rather than figuring it out is that the x-coordinate is negative b over 2a, and the y-coordinate is c minus b squared over 4a. Okay, so I don't expect you to remember that. I would say memorize know the negative b over 2a, this part, and then you can just take the x-coordinate and plug it into the function to get what y is. That's probably the easiest way to do it. So either one is fine, which then means the axis of symmetry, if you started in vertex, if you started in standard form, then the axis of symmetry is x equals negative b over 2a. All right, so if you start out with, so I'm going to move on to the next thing. So finding max and min values of a parabola, okay? Like I said, if you start in standard form, right, the vertex is either going to be the maximum or the minimum. And then the way you find it is with that little formula that I showed you. So I'll write that down for you. All right, so that's if you start in standard form, okay, where A, B, and C are numbers. All right, so for example, say your function was 2x squared plus x minus 3. This is standard form, 2x squared plus x minus 3. But a, in this case, is 2. B, what's B? 1, yes, not 0, because if it was 0, you wouldn't have an x. And C, because it's 0 times x, then you wouldn't have any x. And then C is negative 3. So if you want your vertex, you find the x-coordinate, which is, your x-coordinate, which is negative b, so negative 1 over 2 times a, so 2 times 2 is 4. And then you use that value and plug it into the function. So I would take negative 1/4 and plug it into f. So f of negative 1/4, which is 2 times a 4th squared plus a 4th minus 3. And then you'd simplify that to get the value of y. So I'm going to go ahead and simplify that. So take a look at my work. I just simplified f of negative 1/4 to figure out what the y-coordinate is. So I found that the y-coordinate of the vertex is negative 25 over 8. So that means that my vertex is negative 1/4 and negative 25 over 8. Okay? Now in this case, we also want to know, is this a max or a min? Because that'll be useful for word problems, right? Where they ask you to find the maximum velocity of blah, 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 right? So the way you determine that, right, is that you have this function, 2x squared plus x minus 3. And this number out front, that 2, if it's positive, if a is greater than 0, then it's concave up, or it looks like a smiley face, right? Because he's happy. Yay! He's positive and happy. If a is negative, he's sad and upset. So he looks like a frowny face, which means in the case where a is greater than 0, you have a minimum. Where a is less than 0, you have a maximum. Yeah? Make sense? Cool. All right, let's look at similar situation, but for vertex form. If the function is in vertex form, what do you do? If the function starts in vertex form, which is f of x equals a times x minus h squared plus k, then the vertex is super easy. It is literally h comma k. And remember, since that's a minus h, and since it's your horizontal shift, which is opposite of what you think, right? If it's like, let's say our function is f of x equals negative 2 times x plus 3 squared minus 2, then that plus 3 means it moved left 3, which means your h is actually negative 3, and your k is negative 2. Okay, that's your vertex, which then also means that your axis of symmetry is x equals h, right? Or x equals negative 3. Let me clean that up for you real quick. All right, so the last two examples are just word problems that talk about max and mins that we might use. The first one, you have highway mileage in miles per gallon is approximated by this function. M is the miles per gallon, and S is the speed. So there's a relationship between the speed that you go and the miles per gallon that you get in your car, which makes sense, right? The faster you go, the more you're pressing on the gas, right? The worse your gas mileage gets. So here's the function, right? And the question is, what's the maximum mileage for the compact car to the nearest tenth of a mile per gallon? What speed results in this mileage? So if you think about the function itself, right, negative 0.025 s squared, right, you know it's a parabola, and because that first term is negative, a is negative, it means it's upside down, right, which means that the vertex, which is the maximum point there, that's going to have, that's going to include the max mileage and also the speed at which that occurs, right? So like if I were to actually create axes, right, my x-axis is speed and my y-axis is miles per gallon, which means this point of the vertex, the x-coordinate is the speed at which the max mileage happens, and the y-coordinate is the max mileage. So you can use, I'm going to just write the answer down because I'm running out of time. So try it, check your answer. You're just trying to find the vertex. Since it's in standard form, you know it's a negative b over 2a, so you can figure it out that way. So solve and you find the vertex is 49, 30.025, which means the max, so the speed at which the best miles per gallon happens is at 49 miles per hour, and then the max miles per gallon is 30.025 miles per gallon. Try the second problem. This is about a soccer ball. It reaches its max height here, and then the horizontal distance is the x. Let's go ahead and find the maximum height the ball reaches. And there you have the solution to number 2. All right. Cool. See you guys later.